And Bob, you've got the first item.
Yeah, thank you. So I wanted to have I'm very unprepared again, and I found a bug in recording rules while I was preparing, or at least trying to. But anyway, so I wanted to show where I'm at with recording error budgets for stage groups. Let me share my screen. This is the issue that I was working on. As you see, we've started by making sure we've got all the source metrics in place. The source metrics are error rates, total operation rates, AppDex success rates, and total AppDex measurement rates. We're calling them scores for now, and then a mapping of feature categories to stage groups. So we've got all those in place now. And then now we're going to aggregate the feature categories, all of these metrics that we have for feature categories up into success and error rates for stage groups, and we're going to use the mapping that we've defined here to do that. And I've started that off in this merge request. The meat of that, of the changes here, lives in the aggregation sets. So yeah, these are some rates that we forgot, but this is the main thing. So we're defining the stage groups aggregation set, and then later we're going to take the feature category aggregation set and use it as a source for this one. And then to add the mapping on top of that, I added this bit, and this is the thing that I would like some input on from all of you, if anybody has a thought. So this is the mapping. It contains feature category label and stage group label and the product stage label that we want to have on the metrics that we'll be recording here. And the way I'm adding that is like joining it in a string like this. Yeah, that's where I'm at.
I think I really need to go through this actually and mess around with it on my computer, because it's yeah, like I think that's the best way to kind of for me to give input into this.
If you want to play together on that later, I'm happy to.
Cool. Okay. Can you just make sure we don't have like any incidents or?
No, I
no,
can't.
joking. No, it's fine.
If I knew how to do that, would I be building this?
Don't start another incident, Bob.
Okay, because you asked nicely. One thing that I did want to point out that is a bit weird, that I just noticed before the call, which made me say that I'm not prepared. Like, we want to record a success rate here, and for some reason we're summing the weight. So I need to see what's going on and if that's a problem with other recordings as well. Yeah, that's where I'm at for now. Thank you, everyone.
Let's do some pairing on that, because yeah.
Stop share. I can't stop share.
You have stopped sharing. That's fine.
Oh, okay. The thing says I haven't. The next one is Jakob, I think.
Okay, thanks, Bob. Now I'm going to start share. I have two items. One is about an experiment we did where we bypassed the CI pre-clone script. Actually, we don't, well, this was the change issue for it. So the pack objects cache we're building, we're not calling it pack file cache anymore because pack files also are, I don't even want to go into why it's confusing, but unless somebody wants me to, but I think it's confusing to call it pack file cache, so I'm calling it pack objects cache now. Well, the thing that prompted this project was the realization on my part how important the CI pre-clone script is, which is a custom thing we have for GitLab or GitLab, without which the server that the Gitly server that GitLab or GitLab sits on melts down because of all the CI clones. And we've been experimenting with the cache, the back objects cache in the past couple of weeks. And sort of as the final experiment, I wanted to see what happens if we just bypass the pre-clone script. And this is an interesting test because we know from incidents in December that normally if you don't have the script, the server melts down. The server did not melt down. That's the short version of it. It was a bit tricky to, Andrew is excited. It was a bit tricky to figure out how to bypass this because at first I tried to tweak the script so that it would exit without doing stuff a percentage of the time, but I ran into all sorts of bugs in the script and I realized after a while I just need to not touch this script because it works, and the moment you change anything it might stop working, and then just don't do that. So what we did in the end was that there's a setting in the project settings where you can say I want to do a fetch on each CI build or a full clone. And I just toggled that to clone. And the result was that the pre-clone script still ran and downloaded stuff. And then the CI runner came in and RF'd everything that the pre-clone script did and did the clone again. A partial clone, not a full clone. So that was the simplest way to bypass it. And when we did that, one of the most obvious things that happened was this on the network transmit rate. So this is for the window where it happened. You can see when we made the switch. So here it's around 50 megabytes per second, and here we are in the 200 to 250 megabytes per second on the network egress rate. And the reason for that is that the pre-clone script works by making the CI runners fetch less data. And when I do spot checks, it looks like they fetch between 10 and 100 kilobytes of data each. And that is great. But if you don't do that and you do a partial clone, then you fetch 120 megabytes of data. So each of these CI runners was fetching maybe 1,000 times as many bytes. And that doesn't really add up because 250 is not 1,000 times 50. You'd expect more. But it does make sense that the network egress rate goes up a lot because all these builds are now much bigger. But the good news is that there's a big bump here on this. But if I look at the dashboard for what happened then, and let's see, yes, we're looking at file scenario 1. This is the same time window. You just see nothing interesting. Well, if you scroll down, you see something interesting here. So you can see this is where we were doing bypassing the pre-clone script, and there are more open file descriptors. There's also more threads. And you can see here in this one that there are more upload back processes. Now, my guess / head wavy explanation for this is that because we're downloading more data, each upload back process runs for a longer amount of time, just because sending 120 megabytes will take longer than sending 100 kilobytes. And that means all these processes that would normally finish, some of them would finish one after the other, now they will overlap. So that's why there were more processes. But if you look here, the CPU does not look much worse, although there is that interesting spike there. And I'm not sure what that's about. But yeah, in the grand scheme of things, that we would have had 100% CPU and incidents and all sorts of stuff going wrong if we would have done this in December. So the fact that this just held up is nice. And one more thing before I hand over the stop talking. So that's the network transmit rate. That is very clear that went up. This metric shows the number of bytes served by the cache, and I need to change that to a 10-minute thing, then it looks the same. So that goes up pretty much as much as that one by the same factor. The amount of bytes generated doesn't change that much. That's surprising because the things we're cloning are the things CI runners are cloning in that window are 120 megabytes instead of 100 kilobytes. So you'd also think more bytes are going into the cache, but you barely see a difference here. There is a little bit of a difference. And then the last graph I wanted to show was the disk size of the cache. And there you can see that here it dips to almost 0 more often. And while we were doing the bigger clones, it never dips to 0. So you can tell from that there are more bytes in there, but I was bracing myself for a bigger impact on the number of bytes that go into the cache, and that was just sort of barely, well, not all that interesting. Like the only really notable part that I saw was way more bytes going out and more processes running at the same time.
Could you like I'm trying to like think about what the first graph you showed that you didn't expect. What was it? The bytes generated.
Yeah.
Could that be like the reason we don't like that there isn't such a difference there is that in the grand scheme of things, lots of other things, not CI, are also generating bytes from this project, or?
Yes, there
Because
are other.
the CI is only generating it once now, no, because of what you built. So that's not that much in the grand scheme of things, or?
Yeah, but still, there would be. Yeah, there is other traffic clearly, and whatever CI is doing in terms of bytes apparently is not as much as the other traffic.
Because it's only doing it once for every.
Yeah. No, I mean, that's the amazing thing about this cache, because it is. The cache is relatively complex, but that's because it's tries very hard to only do it exactly once, do the work exactly once, and not, because if you naively build a cache, you can have two things that produce the same cache entry, and then one of them gets thrown away. And it's built the way it is so that you never throw something away. You only do the work once. But still, we're going from putting things into the cache that are 100 kilobytes to putting things into the cache that are 120 megabytes. So I struggle. I think you're right. There's other traffic going on that is dominating here, but I'm surprised that the deduplication works this well.
Can't you just be happy?
I am happy. I think I am a little bit nervous about this, the egress rate, because
That used to come from object storage.
yes, exactly. And there is going to be a limit at some point of how many bytes we can pump out of that one GitLab server. So maybe at one point we'll need read scaling just for the network pipe, but there's always going to be a bottleneck somewhere. And I guess.
But
go ahead.
Google tell us that the network is infinite.
Okay.
That's what they say.
But there is a network card on that GitLab server,
Magic
right?
network card.
It's a magic network card. Okay.
Yeah, didn't you see that it's like the infinite one and has the infinite sign?
Oh, okay. Okay. So yeah, I have no idea what will happen, but it's yeah. Yes, Bob, I am happy. It's just it's kind of like amazing that it can do this, and yeah, it's not melting down.
How does this tie in with prefects distributing reads?
Well, it's orthogonal. So if this thing is not sitting behind prefect, and if it was
but in a different case,
yeah, if it was sitting behind prefect, then on each GitLab replica behind prefect, cache. Yeah, yes, that'd be separate cache.
Yeah. So we lower the hit rate, but we increase the distribution, if you want.
Yeah. And if there's projects where the number of concurrent clones is lower than the number of replicas, then you're not going to see a benefit from the cache. But with
like you could, to a point, almost direct the same traffic to the same node in prefect, so that it actually artificially inflates the cache hit rate.
Yeah.
But yeah, so that's
but
out of scope.
The interesting thing
it's not a problem. Yeah.
No, and No, exactly. The hit rate goes down, but you still get the benefit of only one process doing that job, the deduplication of the processes for each individual replica. Yeah. Okay. Well, if there's no other questions, then I also have the next item, which is a small thing I noticed when I started writing the documentation for the feature, which is that, and this is probably not going to be true in the general case, because we've been doing the experiments on Prefect, the Prefect cluster, and on Canario 1, which both have very few repos on them. Like most normal Gitli servers have lots of different repos on them, but these are sort of, I don't know, test beds where we don't have a lot of different repos. And the reason I'm saying this is that if there's not a lot of different repos, there's not a lot of Git data on disk in the grand scheme of things, and it all fits in memory. And we're not going to stuff the page cache full of Git repository files. Because the interesting thing that's happening that I notice is that on file prefect 1, and maybe I should just now look at the time when we did the experiment. So there we go. This is bytes served again, and you can see it peaking. But if we look at disk reads in that time, then it's 100 kilobytes per second here peaking on disk reads. And in this graph, we're serving over 200 megabytes per second. And just to be clear, this is a counter that correlates directly to read system calls. So we're asking the Linux kernel, please read these bytes from a file. So this is, from the point of view of the read system call, this is how many bytes per second we're reading from files. But then at the level of the disk underneath, we're only reading 100 kilobytes per second. And the reason for that, I think, is the Linux page cache, which means that if you try to read files from disk, Linux keeps them in memory, because so that if you read them again, it doesn't have to read them from disk again. And these machines have so much memory that our entire cache in this window, actually this graph is wrong, because this is showing Prefect, it's not showing Canary. So the experiment is not in here, but it doesn't, Prefect is still pumping out a lot of data here, right? I'm looking at the same servers, and the cache, it's in principle it's on disk, but in practice it's in RAM, because the Linux page cache keeps it in RAM. And if we would have put the cache in object storage, we wouldn't have had this effect, because there is no page cache for object storage. But because we're reading from disk, the Linux, like, as long as there's not enough RAM available, Linux puts the cache in RAM for us. That's what I wanted to share.
When you were saying that, I had that image of the magic GIF, except instead of saying magic, it said Linux.
Yeah, yes. Yeah, it's quite, and I've been thinking about it more, because it's, even if we were memory constrained, there's the effect that we have the producer writing into the file, and all the consumers must read from the file. So all the back objects data must go through the file in a way. But because of the page cache, if you have a reader that's right behind the writer, the thing the reader wants to read is by definition still in RAM, because Linux hasn't even written it to disk yet. So somehow this design, by luck, I think, because I didn't plan it this way, but by luck, it cooperates very well. It looks like it cooperates very well with the page cache.
How will that look on busy servers?
Sorry?
How will that look on busy servers with lots of different repositories?
More data will be paged in from disk, but Linux will try to balance it somehow. The one thing that can happen that is less than ideal is that repository data gets paged out, that needs to get paged back in. But um,
what kind of monitoring can we do to make sure that the buffers and cache that we have available on those machines is sufficient, that it's sufficiently tuned? And this is where having Matt joining the team will be great. I suspect.
I think we already have metrics for page faults, because what this is called is a page fault. So if
Is it, but a page fault isn't about like the kind of excess memory, if you want, is all used for buffers, and that tends to shrink down, and that's not page faults, is it?
I think a page fault is when you want to read something and it's not in the cache and you have to get it from disk, irrespective of what it's for.
Okay.
But okay, Matt will help. One thing I want to say here is that I'm not sure how much control we have. There are some tunables in the Linux kernel over how it chooses what to do with these buffers, but
the main tunable I was thinking of was
box.
actually the amount of memory that we have. You know, and you know, would it make sense in some cases to have extra memory on the machines because you know they would be much more efficient with it.
Or maybe in some cases it is smart to do what we are already doing, which is to isolate busy repositories on their own servers so that all their disk data sits in RAM anyway, and they get accelerated that way. But I don't know enough about the page cache to see exactly what the mix is between these different things. I just noticed that if I look at these graphs of what's happening on these couple of guinea pig servers, then I can see that apparently we're not reading from disk, or barely.
Superb. So what's the next step?
The next step is that we make the cache configurable via Chef, because right now it uses hard-coded config values and you can only turn it on and off with a feature flag. So it should have a config value that says on, off per server. And so I need to do a couple of merge requests for that, and I write some documentation. But I think the moment it is configurable via Chef, I'm going to raise an issue to have it rolled out.
So, Jakob, sorry, I might be missing something, but is there a reason why we couldn't use the feature flag to just roll it out to a percentage of users now? Parallel, rather, to the configuration changes?
If we wanted to roll it out now with the feature flag, we could. I just, we don't have very fine-grained control with the feature flag. So one thing that I'm slightly concerned about is the file HDD servers, because they have slower disks. And we don't have a way to say this is on everywhere except on file HDD right now. We can only say it is on for projects, or a percentage of projects where it's sort of the set of projects gets picked randomly by the feature flag mechanism, or it's on a percentage of time, but we cannot turn it on and off for individual servers.
But do we know?
Go ahead, man.
I wanted to say that we can expect that file HDD projects don't actually get a lot of traffic because they're supposed to be
they might be fine,
archived, right? So maybe if you feel comfortable doing this, I would rather want to see this running in parallel. If we can do a percentage of traffic, while, right, like if you run this and we kind of observe it while the configuration is being written, we kind of get best of both worlds. Like you can get maybe like edge cases if we see edge cases, and we can then stop the configuration work because it's more important to actually fix the actual operations, right?
Yeah. So the idea of the experiments so far has been to look for edge cases. And at this point, I think we're going to be fine with edge cases. And the configuration work, the GitLab merge request is already approved by one reviewer, and the omnibus merge request is, I want to check it manually. But what I'm trying to say is that up to the configuration work is almost done. So I'm not sure how much time we gain by starting a percentage of time rollout in parallel, but we could.
The reason why I'm telling you this is because we are basically fully blocked.
But we still have the gem problem.
We are like we're digging ourselves out of it, but apparently there is also like a big OpenSSL vulnerability announcement today, so that's going to be fun. So my point being, there are delays with everything else that is happening, and given that you actually have a tool to start rolling this out and see what kind of pressure it creates in the infrastructure, right? Like if we in this situation where we are at now can enable this and it still works and the platform works, it means that in peace times, it's going to actually work really, really well, right? Like it's going to, you know?
So I'm not blocked yet, but the moment I get blocked, I can raise an issue because I already started a bunch of things. It doesn't make sense to drop them if I can keep moving them along, right?
Agreed.
Yeah.
Just also keep in mind the distribution team who is supposed to be reviewing those things have 15 different priorities that are being now put as highest top best priority.
Yeah, I noticed actually I tried to do a test build on my omnibus merge request and nothing happens, and I figured it has to do with the gem problem or something. So I might realize I'm blocked pretty soon today. So that's a good suggestion to just do the percentage of time thing and learn more that way. Thanks.
Awesome. Thanks. Excited about this. Super excited about this.
Great. I think that, wait, that was it. Or at least that was my part of the agenda, my part.
Is there anything else that anyone would like to demo or chat about? Great, well, then we can have half an hour back. Thanks, everyone. Hope you have a good rest of your day.